In the previous video, we talked about how to write fractions as a decimal. So if I wanted to like write the fraction 27 over like 15, if I wanted to take that fraction and write it as a decimal, we would know how to do it. We could just do like the division algorithm to it and sort of go from there. And we might get a repeating decimal from doing something like that. So whenever you take a fraction and then just and then do that algorithm, you're going to get a repeating decimal. And so the question that I want to explore in this video is, how do we go backwards? So how do I take a repeating decimal and convert that repeating decimal into a fraction? Right. So let's use the example of 0.12 repeating. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, something like this. So that's our number. So the trick here is we're going to use a variable. We're going to call this n. So n is just this number 0.12 repeating. Okay. So this repeats every two place values. And so the trick here, after we assign this variable, the trick is to multiply both of these at the same time by 100. Okay, so I multiply both sides by 100, so I get 100n on the left. And what do I get on the right? Well, when I multiply by 100, that's just going to shift the decimal over two places. And so I'm going to get 12.12 repeating. Okay. And so now from here, we can just subtract these equations. So I'm just going to copy this over here, and then I'm just going to subtract this. And so on the left, we get 100n minus 1n is equal to 99n. And on the right, what do we get? Well, we have 12.12 repeating minus just 0.12 repeating. So all of these 1, 2 repeating parts, whatever you want to call it. So all of those are just going to go away, and we're just going to be left with 12. And so we can divide by 99 and get that n is equal to 12 over 99. So 12 over 99 is equal to 0.12 repeating. So 0.12 repeating is equal to 12 over 99 as a fraction. And you could check that by just doing the division algorithm we talked about last time or in the previous video, or just put it into a calculator and see what is 12 over 99 equal to, and you will see that it's equal to 0.12 repeating. Okay. All right, why did we multiply by 100? We multiplied by 100 because it repeats every two decimal places. So if it repeats every two decimal places, then when we multiply by 100, we'll just get like the 12 to the left of the decimal, and then to the right of the decimal, we'll have the same repeating fraction that we had before. Like if we multiplied by 10 instead, then we would get like 10n equals like 1.21 repeating. So 1.21 repeating. So then if we did that, then we wouldn't be able to like cleanly subtract that from we wouldn't be able to like cleanly just subtract this from this or whatever. So let's do another example where we have something where we don't have to multiply by 100. So let's say that we want to convert 0.123 repeating to a decimal. So let's call this n again. And now this repeats every three decimals. So I'm just going to rewrite this. 1, 2, 3, 1, 2, 3, 1, 2, 3, so on. So it repeats every three decimals. So I want to move the decimal 3 to the right. And to do that, I'm going to be multiplying by 1,000. So that moves the decimal 3 to the right. So 123.123 repeating. And now I want to subtract these equations from each other. So subtract n over here, subtract 0.123 repeating over here. And what do we get? We get 1,000 minus 1 is 999 n. And when we cut off the repeating decimal part over here, we just get 123. So n is equal to 123 over 999. Great, so that's how you do it. And that sort of approach will work for any repeating decimal. You could have like a really long repeating decimal, like you had 1, 3, 4, 5, 7 repeating. You would multiply by just 10 to the 5th. So what's that, 100,000? So we could do that. The approach gets a little bit more complicated if you have something like, say, 12.1. Let me use some different digits, and then like 3, 4 repeating or something like that. So 12.1, 3, 4 repeating. So this, you would have to handle this a little bit differently, but we're not going to get into that. Maybe in another time we'll get into that then. But for now, just sort of get comfortable with this approach up here.